Welcome back to Learning with me, Ms. Killen here at MPB. We are in our 9th unit. We are looking at functions, a review of linear, quadratic, and exponential. Today's lesson is lesson 1, how all three can be compared. I can show similarities of all three functions with their key features of equations and graphs. Now today we are looking at F, IF4, and LE1. So let's go ahead and jump into it. Now, in this 9th unit, we are going to do a lot of comparing and a lot of contrasting. So, up until this point, if you've not kept a lot of good detailed notes, you might want to start now because some of these things, if you don't keep them exactly on track, they can get confusing. So, just wanted to tell you that. So let's look at this. It says, let's complete information tables on each of the functions. Now, these need to either go in your notes page or somewhere that you're going to take notes. I promise you, you are going to want to take notes on these. So here we go. So the first one we're going to look at is our linear functions. So here's our table, and we are looking at linear. So it says questions of our linear functions. Now, first of all, how are my linear functions graphed? Well, that's easier for us to remember. When we put a linear function in, it's a straight line. So I'm going to go ahead and mark that as a straight line. Now, the next one says the equation. Now, we've seen a good many equations when it comes to our linear functions, but the most that we've seen is y equals mx plus b. Sometimes we may also reference to ax plus by equals c. Now my x-intercepts, they are also known as zeros, and they're going to have a number and then a zero, or it's not zeros, it is just a zero because we only have the one for a linear equation, and we're either going to have no x-intercepts, one x-intercepts, or sometimes, depending on how that linear function looks, it may go all the way across the x-axis. So I could say we have an infinity amount of x-intercepts. So now we're looking at the y-intercept, all right? This is also going to have one, just one. And then it's going to have a zero, and it's going to have a number. And when we have our y-intercepts, it's known as the b in our equation. And we saw it up here. That's our y-intercept. Now, what about our domain? Now, we say that our domain for our linear equations are x such that x is all elements of real numbers. We could also say that our domain runs from negative infinity to positive infinity. Our range is also said to be y such that y is all elements of real numbers, and that y can also go from negative infinity to positive infinity. Now, we do not have a vertex for our linear functions. We just don't have that. Now, what about our rate of change? My rate of change is going to be constant, and it's also going to be known as my rise over run. And sometimes we'll see it as y2 minus y1 over x2 minus x1. So this is all the information that we need to know about those linear functions. Now, we've learned all of this. We've talked about how it's represented as a straight line. We've looked at that y equals mx plus b, or that standard form. We know that it's a zero for my y-intercept, or excuse me, my y value, and then a number for that x-intercept. And we talked about that our b in my equation is my y-intercept. And we talked about how to look at those domain and ranges. We've also looked at the rate of change, or my slope, which is constant for this linear equation. So you want to make sure that you're remembering all of this. Now, if there's something that we put up here and you're not quite remembering it, go back and look in your notes. Go back and look at some videos. Maybe there was something that you missed. Go ahead and grab that knowledge now, so as we go forward, you've already got it under your belt. All right, so let's look at the next one. So the next one is our quadratic function. We are doing a table on quadratics. So let me go ahead and grab a different color than the red. All right, so obviously we said we are doing quadratics. Now, how is this function represented? This function is represented by a parabola. It looks like that. Now, my equation or equations for my quadratics, we could say is f of x equals ax squared plus bx plus c. Could also be y equals a times x minus k squared. We could also see the y equals ax squared plus bx plus c. So there's multiple ways that we can see those equations for this quadratic. Now let's look at that x and y intercept. Now, unlike linear, when I talk about my x-intercepts, I am either going to have 0, 1, or 2. We also call these x-intercepts zeros. And it looks like a number and a 0. Now my y-intercept, we are going to usually have just the 1. We're just having one y-intercept. Now when we talk about this rate of change, this rate of change is different. It's not necessarily constant. So it's not a constant, but we are constantly changing. All right. So our domain is same as the other. X is such that X is all elements of real numbers. So is our range X such, not X, because our range deals with what? Yep, deals with Y. So Y such that Y is all elements of all real numbers. Now, I do have a vertex. I have one vertex, and that is known as my H and my K values. I do have an axis of symmetry going up through that vertex on the X value, and we say that X equals opposite of B over 2A. So I want us to make sure that when we compare this linear and we compare this quadratic, we can see how they may be similar, how they may be different. I want us to make sure that we're notating all of those differences and all of those similarities. Good job. Let's look at the next one. One thing I do want us to know real fast about this rate of change, so I have it as not as constant, but it's constantly changing, but I also want to put but, because that is a, look at me word, but the change is at a constant rate. So I don't have a constant rate of change, but I do have a change at a constant rate. So it is constantly changing. So I did want to put that as a little bit more detail about that rate of change. All right, so here is our next one, which is our exponential function. So here is our table for these exponential functions. So let's go ahead and look. So I'm looking at exponential functions. Let me grab this. So I'm going to put exponential. All right, so how is this one represented? How did we say that our exponential is represented? So it may be slow to start. Then it's a rapid increase or a decrease. Depending on if it is a growth or decay, is going to be if it's increasing rapidly or if it's a decreasing rapidly. So it's usually slow to start because remember we have to change from one point to the next. So the way we change depends on our previous point. So it may start out slow and then go up rapidly, or it may start out slow and then decrease rapidly. So you have to make sure that you look to see how it is graphed. So let's look at this. The equations that we're using. When we looked at this equation, we looked at y equals a times b to the x, where a does not equal 0 and b is bigger than 0. And we also said that a is my y-intercept, b is my common ratio. All right. So then we have our x-intercept and our y-intercept. So my x-intercept, sometimes I'm either going to have 0 or 1. My y-intercepts, I'm going to have 1. My domain and my range, my domain is like the others as x, such that x is all elements of real numbers. But my range is a little different. So I want us to make sure that we are taking note of the difference of that range. So let's go ahead and look at the range. So my range is y, such that y is greater than some constant. And we went over how those y's can be larger. And then we can also say that y such that y is not greater than or equal to some constant. So we really need to make sure that we are going back and looking at those exponential functions, because as of the 3 that we've gone over so far, this one had the most that we really had to dig deep into. So I want us to make sure that we are gathering all this information about these exponential functions. So let's look at the vertices. All right, so when I look at vertices, we do not have any, so there are none. Now my common ratio, this is going to be my rate of change. And like we said, we look to previous point. So that is a big, big, big point that we've got to make sure that we're understanding about this common ratio. So our ending behavior, when I have a base, which is greater than 1, or I have 0, which is less than my base, which is less than 1. Now, if my base is bigger than 1, that's where I have this growth. And I think I put this on the wrong line, guys, but we can fix that. And then when my base is between 0 and 1, this is my decay. Now you may be going, Ms. Kellen, what are you talking about? Remember when we said that A, if it is greater than 1, what type of problem we had? Not our A, but our B. When we said that our B, our base, our B is greater than 1, we had some type of growth. Or when our base, which is our B, was between 0 and 1, which is a fraction or a decimal, we had a decay. That's what this is meaning, the base. So we see it as B up here and B over here, but it's actually base, all right? So now let's go back to the rate of change. And we said that our rate of change is how the graph behaves. Like we said here, we look at that previous point. So that's how we're looking at this rate of change. We are having to show that we're looking at that previous point, and then depending on what that base is how it's going to change from point to point. So there's a lot of good information in this chart. There's a lot of good information that we gathered about these exponential, quadratic, and linear functions. You're going to want to make sure that you are reviewing those notes about them as we go further in this unit, just to make sure that we've got it. All right, here we go. It says, wow, remember that we have learned our calculator skills and we've learned Desmos. Do not forget to use them. Those are your tools that are going to help you when you're looking at these different types of functions. Don't forget them. All right, so it says put the letter by each name, or by its name. So I've got a type of function here, a type of function here, and a type of function here. Well, which one is what? So we have a quadratic, we have a linear, and exponential. I want you to take like 5 seconds, look at the video's screen, and tell yourself or tell your table partner what A is, what B is, what C is, and we'll see what we got. All right, so I'm just going to write underneath the picture of the different graphs what they are, and let's see if you got the same thing I did. Here we go. So A, I'm going to say is linear because it's one represented by a straight line, and I have y equals mx plus my b. All right, so my middle one, I am gradually starting and then rapidly increasing, or I'm gradually starting and rapidly decreasing. So this is going to be my exponential. And then I have loads of parabolas. Just look at all the parabolas, and we know a parabola is considered a quadratic. Is that what you got? Is that what you and your table partner got? Did y'all get linear, exponential, quadratic? All right, we've got to make sure that not only can we identify them by looking at them, but by also looking at their equations. Good job. So let's go. It says, let's try our technology tools. Guys, technology is going to be the key in getting through a lot of these. So we don't need to throw them away. We need to make sure that we are really understanding how to use them. So here we go. Use both tools for the function. Here's the activity. For the following activity, use both calculators, meaning Desmos and your TI-84, to help sketch the different functions. And Ms. Killen misspelt it. She does apologize for that. On your notes page, make sure you notice how the functions are represented in the equation form and graph form. Using different colors may help with understanding the different representations. So now that we've got the instructions for our activity, let's see what we're doing with these instructions. So it says use the following functions to sketch. So we're wanting to use each one of these equations which represents a function, and we want to sketch them to see what they look like. You can either use your TI-80 or TI-84 or your Desmos. Now if you do use that TI-84, you're going to have to get them in the formulas that we've learned. We had y equals mx plus b. We had ax squared plus bx plus c. And we had a times b to the x. Either way that you choose to do these is perfectly fine. Now, if this is your best bet, do it. That's going to be the best way that you learn. Some of us have a hard time moving around and getting them into the formulas. So Desmos may be our best bet. I can plug them into Desmos just the way they are and see what they look like. I'm going to use Desmos just for time's sake. So let's go ahead and pull up Desmos, and I'm going to put these in, and you'll see the different colors as I put them in. So we've got, the first one was y plus 2x equals 3. And so I can see my red line represents that linear function. So let's look at the next one. So my next one was y minus 3 equals 6 parentheses x minus 2 close parentheses. So let's see what we got here. So I've got, that is another linear equation. So we see that that's a linear equation. So let's look at the last one. So I am going to do x divided by 2, and then I'm going to do plus, whoops. Before I can do the plus, I have to arrow out of the fraction, plus y divided by 3, arrowing out of the fraction, equals 1. Yet another linear function. But Ms. Killen, they looked so differently when I saw them. They did look differently. But don't let the way they look distract you from how they're going to graph. Could I put them back into that y equals mx plus b? Or did I need to put them into that quadratic formula? Make sure that you not only look to see what it is telling you, but can you put it back into that type of formula? All right, so let's go back. All right, so let's look at the next one. And we've already done this. This is a page just in your notes if you wanted to go ahead and sketch them. I did it on Desmos just for time. So here's the next one. Use the following functions to sketch. So I have g of x, y equals, and f of x. Now, I'm noticing some things here, so we need to make sure that we are noticing how they're written, and so we know how to plug them in. So again, I'm going to use Desmos just for sake of time. All right, and I'm going to plug them in. So here we go. So my first one that we have is, we have g of x, which we know as y equals. So I have y equals, and I have 2 to the x. Now, for me to do 2 to the x, I'm going to hit this a to the b so I can put x as my exponent and arrow out. And then I'm going to put plus 9x plus 35. And let's pull this down and see what it looks like. Now, I can see that it is not linear. It is not linear. It's got some type of curve. It's not a quadratic because it's not a parabola. So this one is a what? It's an exponential function. So sometimes you may have to maybe scroll out or maybe zoom out to see the full effect, or you may need to scroll in to see the full effect. So that's why we have these different keys over here to help us. So let's put the next one in. Here we go. So I've got y equals, and I have x squared plus x minus 6. Now, let's look at this one. I am going to scroll in. Look at this. What would we call this one? It's a parabola, because I can see I have a vertex, I have 2 x-intercepts, I have 1 y-intercept, so this one would definitely considered a parabola. Let's look at the last one. So I have f of x, which is the same thing as y equals, and I have 2x squared minus 6 plus x. And let's see what this one looks like. This one is again a parabola. We see the parabola, therefore it's a quadratic. I have my x-intercepts, I have my y-intercepts, I have my axis of symmetry through my vertex. So all of these different key and components that we've learned is being shown in these different graphs. Good job. All right, so let's next look, see what we got. All right, so here's our last one that we're going to look at. Now, obviously, we see what type of functions. We see exponential, but we want to just double check ourselves, double check our work to make sure that it is a true exponential the way it looks. So we're going to go back to Desmos, and let me plug these in. So I've got f of x, which is the same thing as y equals. And then I have 4. I'm going to put times, and then I'm going to have what? 3 to the x. There it is. That is like the perfect looking exponential function. All right, let's put the next one in. So then I have parentheses 0.75, close parentheses. Whoop, Miss Killen, you didn't put y equals. She sure didn't. So let's try this again. Parentheses 0.75 to the x. This one is a decreasing or a decay exponential function. So let's try the last one, see what it looks like. So h of x, which is the same thing as y equals, and I'm going to put 1/2, and then I'm going to put a parentheses 5 to the x. Whoops, Miss Killen, that didn't quite go. It sure didn't, because I did not scroll out of my fraction. So got to make sure we scroll out of them fractions. Now I'm going to put my parentheses of 5 to the x. And look at this one. It's another growth or another increasing function. So depending on which way it's going or which way it's going depends on if it's a growth or decay. So we need to make sure that we're remembering those. Good job. All right, so let's go back. Now, let's remember what the key features of the 3 functions are, and Ms. Killen is still mistyping. She does apologize. And what they represent. Don't forget how the graphs look. Sometimes it's going to say in your question or assignment, is this compared to the graph linear, quadratic, or exponential? So we've got to make sure we know what they look like. All right, so I am going to have a great time reviewing with you of all of these different words and these different functions that we've learned. We've got to make sure that we're taking notes on these. We've got to make sure that we can compare them, and we've got to make sure that we can contrast them, because depending on what type of function they are, depends on what we do with them. We've got to make sure that we're understanding those common ratios. We've got to make sure that we're understanding that axis of symmetry and the range and the domain and all these different words that go with all of these functions that we've learned so far. So, got to make sure that we're taking those notes. I'm so glad you came to learn here with me at MPB. I'm having a great time with these functions. I hope you do too. I want you to have an awesome day.